All right, welcome to another part of complex numbers. In front of you, you have complex expressions that needs to be factorized. One thing you will notice here, something different from real numbers and complex numbers, is that in a real numbers we have difference of two squares, that something of this kind, x squared minus 4, which is the difference of two squares. But in a complex situation, we have sum of two squares, right? So this is one thing that you need to notice, and that needs to be taken care of in terms of factorizing and doing all that of stuff when it comes to dealing with complex expressions and equations. Now here, number one, we have sum of two squares. So what do we do to factorize this one? Simple as just to open two brackets. Then you are going to be having the square root of 4 is 2. Then we have 2, usually have plus or minus, even in a real situation. Now in complex situation, we have plus or minus. But the only thing that is going to be different now, when you are having sum of two squares, you are going to be having this I, because there is an imaginary part of the solution. So we have these are the factors of the very first question. Now, in the second one, it is going to be done the same way that we have x and x. Then the square root of 16 is 4. Then we have 4. Then you just put I and I if you're dealing with what? Sum of two squares. But the signs between these two things are the same as the real situation. So we have x minus 4i. Then we have x plus 4i. Coming to the third one, it is done the same way as well. It's just that 8 is not the perfect square number. But anyway, we can find the square root of 8, which is equal to 2 root 2. Then we put I. We have 2 root 2. Then we put I. Then we have these signs in the middle. Well, now let's get into number 4. Number 4 is a bit different from the first three examples, because we have a trinomial here. But the idea is to make the sum of two numbers, sum of two square numbers. Now what are we having? We need to make the sum of two squares. We need to make the sum of two squares, such as something that we've been dealing with over there. Now, how do we do that? This expression we can break it down in a sense that one part can be factorized to be a perfect square number. Then we add another perfect square number, such as if we can change this one to be x squared, then plus 8x. Then how about us having 16, then plus 9, because 16 plus 9 is of course 25. So we haven't done any change here, but we just broke down this 25 to be 16 plus 9, such that these first three terms can be factorized in a form of x plus 4. Then we also have another x plus 4, then plus 9. Okay, so this is actually the perfect square number that can be squeezed right in this way, so that we have sum of two squares. Yeah, so which means this expression we have here is changed to be in this situation, so that it is done, or it is performed the very first way of that we have done in the first three questions. So this one, how do we factorize this one? We know we have to take this one first. City x plus 4, open and close brackets. Then we have x plus 4, then close brackets. So we find the square root of 9 is of course 3. Then we have 3 over there. So we have plus, we have minus. But because it's sum of two squares, it's not the difference, so we are going to be having some imaginary part in our factors. So this is how it is performed when you have sum of two squares. Otherwise, when you have a trinomial like that, you need to change it to be at least in this form. And you can see that this form is normally be obtained when you doing what when you are completing the square. So you can complete the square from scratch, showing all the steps, but it is not necessarily have to be shown here. So that is why I just used this trick to find it this way. Now coming to number 5. Number 5, you can see that this is also the difference of two squares. So you can see that there will be some real factors and some imaginary factors. Now let's continue. Factorizing this, you are of course going to have x squared minus 1, then you have x squared plus 1, because this is how you factorize the difference of two squares. Now coming to the situation whereby you have to factorize this one, and also this one can now be factorized, because we've been dealing with factorizing the complex part of our complex numbers. Now let me just for now remove this. Then how do you factorize the first factor? The first factor is going to be x minus 1, then you have x plus 1. Of course, that's how we've been doing it. Then the second one, we know it's a complex part of it, so we're going to be having x then plus I, then even x minus I. So it is just that x plus 1i and x minus 1i. So it is factorized to all the uniform linear factors like what we have. So we also had number 6 had x squared, what was it? It was plus 8x then plus 20. So this one can also be done the same way as we did number 4, that we need to complete the square like thing. But anyway, we can just change this trinomial to be in this form, so that we can be able to factorize it. So we have x squared plus what you have f8 squared and 8x. Then in order for us to be able to simplify this way, we can still have 16 then plus 4, because 16 plus 4 is of course 20. So we haven't changed our equation, our expression. It's just breaking down that constant term into 16 plus 4. Now this one can be factorized the same way. We have x plus 4 whole squared then plus 4. Now we can continue solving this one. What are we having? We have x plus 4, then we have x plus 4 again. Then let's deal with this second term. Then the square root of 4 is 2. Then we have 2, then we have plus, we have minus, we have I, because you can see this is the sum of two squared numbers. Then let's get into number 7. Number 7 is a bit different, because now the coefficient of x squared is not 1 as we normally have it here, and it was very simple to deal with that one. Now let's get into this one. How do we go about solving number 7? So let me just wrap this one so that we can at least have enough space for this question, because it seems to be very challenging. Now we are having this idea that we can change this to be in this form, so that we can be able to deal with it. Let me just open this space over here so that this starts from here. Now our 7 will start from here. We have 4x squared minus 4x then plus 17. So we need to change this to be at least in that turning point form. Now what are we having? We have 4x squared minus 4x. I think we need to break down this 17 into that thing that we spoke about, that if we can have 17 is made of 16 plus 1, 16 plus 1, 16 and 1. These are two perfect square numbers. So if we can have 1 here then plus 16 here, I think this one can be factorized to be a perfect square number, like having 2x minus 1 and 2x minus 1. These are the factors of the first 3 terms, that now we can just have that squared plus 16. that now we can now factorize this one to have 2x plus 2x minus 1. Then we also have 2x plus 2x minus 1 again. Then the factors of 16 is of course 4. The square root of 15 is 4. Then you also have 4. Then you have minus. Then you have plus here. Then you have I. Then you have I. So you have factorized that these are the factors of this equation, of this expression, that we have just used that idea of making it to be in a turning point form, just like that. Then let's come to number 8. Number 8, we are having x, because you can see that x is a common factor, so we can remove it. Then we'll be having x squared, then plus 1. Then this one, there is no hard time here because you'll be factorizing this, and plus I. Then you have x minus I. Then you are done. Then do we have any other things? So this is how we can factorize these things. So you can take this one as a homework, that factorize factorizing z to the power of 4, then minus 4 on z squared minus 5. This is the first one. Then the second one is what? It's going to be 2z squared, then plus 200. Then the last one can just be 4z squared, then plus 12z. Sorry, this is 12z, then plus 13. So let me just put z like this so that it can be clear that this is the variable, not 2. So this is what we have. So I hope it is clear to everyone, this one. So this is the homework. Otherwise, see you in the next question video. We're going to be solving some great stuff.